Hey everybody, we are going to do some sample problems here for strong acids and strong bases. And in this video, we're going to go over this sample problem, 16.45. You can take a minute to write it down. You can look it up if you have the book. You can see if you can find the question on it, whatever. Okay, but there's the question, so let's see what we can do to answer this problem. And I have my handy dandy little calculator in the window so that you can see what it looks like when I type it into my calculator. Okay, so let's see, it says calculate the hydroxide ion concentration and pH for 1.5 times 10 to the minus 3 molar strontium hydroxide. So this is 45, right, 16.45. And it is part A. So let's make sure that we do this right. A, and so this is 1.5 times 10 to the minus 3 molar strontium hydroxide. Now, we want to know what the concentration of hydroxide is first. Okay? Now, strong acids and strong bases are a little bit different. Strong bases, when they ionize, the hydroxide completely ionizes off of here. So this guy, for every one of these that dissolves, as my voice cracks and I finally hit puberty, for every one of these that dissolves, strontium hydroxide produces 2 hydroxide ions. Okay, so we have to do a bit of math. Okay, so and the math has to do with stoichiometry. So, and here's how we're going to set it up. Now, I get that some of you may be able to just figure out that there's twice as much, so this is 3 times 10 to the minus 3. But if you're going to show the work, okay, molar SrOH2, and then I like to use the X line, okay? So for every 1 SrOH2, we get 2 hydroxide ions. Okay? And so that is how that works. And so when we do this, we get 3.0 times 10 to the minus 3 molar equals the hydroxide ion concentration. Okay? Okay, so now we want to find the pH. Now, there is no direct way to determine the pH given the hydroxide ion concentration. So we have to do it one of two ways. We either have to calculate the pOH and go to the pH, or we have to go to the concentration of the hydronium ion and then to the pH. I prefer this way because the math to me is easier. Okay, so that's what I'm going to do. Okay, so now we go pOH equals negative log the concentration of the hydroxide ion. So what's the concentration of the hydroxide ion? Okay, well, it's negative log of 3.0 times 10 to the, and I use E all the time because it makes that term all one term. Okay, times 10 to the negative 3, end parenthesis. And so now we get a pOH equal to 2.52. Okay, great. That's the pOH. Now we need to get to pH. pH plus pOH equals 14. Oh, well, if we have pOH, that means pH plus 2.52 equals 14. Now we subtract, and we get the pH equals 11.48. And I know I did that in my head. Here, 14 minus 2.52. Okay, 11.48. Okay, and so now we have the hydroxide ion and the pH. Okay, so what's part B? Okay, so now we're in grams and milliliters. Okay, so we have 2.25 grams. So for part B here, we have, get this up here, we have 2.250 grams of lithium hydroxide, and it's in 250 milliliters. Okay, so now we have 250 milliliters. So now we need to find the concentration of hydroxide ion. Okay, so in order to do that, we have to have a concentration which is in moles. And for some reason, I use the units when I do this instead of the symbols. But in concentration is in moles per liter. Well, we have to go from grams to moles. So we do what I like to call the X line. Anytime we convert, we can use the X line. Grams, okay, grams on the bottom, moles on the top. And now we actually have to calculate it. Lithium, how many lithiums are there? Well, there's 1 times the mass of lithium, which is right around 7. Oxygen there's 1 of those, so that's 16. Hydrogen, there's 1 of those, and the mass is 1, so that's 7. So that equals 7, 16, 1. Okay, so when you add those up, you get 24 grams per mole, about. Okay, so 24 grams for every 1 mole. Okay, so now we do the math. We math it. 2.250 divided by 24. So what we know is we have 0.09375 moles. Do we have the liters? Yeah, we can convert that to liters. I'll do that in red here. So move it over 3 places. So we have the concentration of lithium hydroxide. Okay, so we have 0.09375 moles over 0.250 liters. Moles per liter. So we take that answer here and we divide it by 0.250. When we do that, we get that the concentration equals 0.375 molar LiOH. So we learned a lesson in the last problem, is that the hydroxide ion is a little funny, and if there's more than 1 in the acid, or in the base, we should probably do a little stoichiometry. But every time one of these dissolves, how many hydroxides are released? Just 1. So the concentration of hydroxide equals 0.375 molar. Now we want to calculate the pH. So we do it the same way that we did up here in part A. Okay, we're going to calculate the pOH equals the negative log of the concentration of the hydroxide ion. And so the negative log of 0.375, and so the pH of this is, or the pOH of this is a whopping 0.426, which means when we calculate the pH plus pOH equals 14, so pH plus 0.426 equals 14, we get that the pH is some very high number, 13.574. That is crazy, but that's the answer. Okay, now the next part. Sometimes I think when I'm making these videos, we are doing marathon sessions. But anyways, 1 milliliter is diluted to 2 liters. Okay, so that's a dilution problem. Okay, so let's figure it out. 1 milliliter. So I'm going to do a new page here. So this is part C of that same problem. Okay, see, so it's 1.0 milliliter of, and I think it was 0.175, but I want to double check. Whoa, hey, get back here. 0.175, yes. So this is 0.175 molar, capital M molar, NaOH is diluted to what? This one. 2 liters. Okay. So is diluted to 2 liters. Okay. So a dilution is when we take one volume and we add water to it so that the concentration is reduced. Okay. The math for a dilution problem is M1V1 equals M2V2. Okay. So what is our first molarity? 0.175. And what is our first volume? Be careful here converting this because we have a lot of decimals that we move over. To go from milliliters to liters, you move it over 3 spots. Okay, equals M2, the new molarity. Okay, and then the new volume, which is 2. So it's 0.175 times 0.001 divided by 2. And so when we do that, we get our new molarity is equal to 8.75 times 10 to the minus 5. And that's our new molarity. And it's the molarity of sodium hydroxide. Sodium hydroxide only gives us 1 hydroxide per molecule. So this molarity of sodium hydroxide is equal to the molarity of the hydroxide because the ratio is 1 to 1. So it's 8.75 times 10 to the minus 5. Okay, so now to mix it up, I'm going to calculate the pH, but I'm going to do it the other way. Remember, you can go from here to the concentration of the hydronium ion, and then to the pH. So what I know is that the concentration of the hydroxide ion times the concentration of the hydronium ion equals 10 to the minus 14. Okay, so now we divide by hydroxide, so I'll plug it in, 0.5 times 10 to the minus 5 times the concentration of H3O plus the hydronium ion equals 10 to the minus 14. Okay, so we divide both sides by 8.75, and so we get H3O plus equals, okay, so now watch what I do here. I'm going to type in, because 10 to the minus 14 is not 10e14, because remember, e means times 10 to the. So what we have to do when we type in 10 to the negative 14, we actually have to do 1e negative 14. That means 1 times 10 to the negative 14. If you do it the other way, then you're going to get the wrong answer. Divided by 8.75 times 10 to the minus 5. And so when we get that, we get the concentration of the hydronium ion equals 1.14 times 10 to the minus 10. Great. And so now that means the pH equals the negative log of that value. And so negative log of second answer is equal to, so that means the pH equals 9.94. And there's your pH. Okay? One more that we have to do here. Okay? And so part D, a solution for adding KOH. And so now we're adding we're doing a mixture of these two, and they have different molarities and different volumes. So we have, this is good. Okay. So we have 5 milliliters of 0.105. So again, I'm going to get a new sheet here, and so we get 5 milliliters of 0.105 molar KOH. Okay, and then we have 15 milliliters of potassium hydroxide. Okay, of 9.5 times 10 to the minus 2. Okay, so it's 15 milliliters of 9.5 times 10 to the minus 2 calcium hydroxide. Okay, so there's a lot going on here. Now, to do this problem, we have to know how much hydroxide ion there is in the solution. Okay? And we need to know how much solution there is. Because remember, concentration of anything is equal to moles over liters. Well, we kind of very simply already here have that it's 20 milliliters. So we already know that we have 0.020 liters of solution. Okay? That's kind of straightforward. But how much hydroxide? Well, this guy gives hydroxide and this guy gives hydroxide. So if we take those values of hydroxide and add them together, we should have the total amount of hydroxide ion. Okay? And we can divide it by the liters, and that is good. So now let's figure this out. Okay? So this kind of combines all the stuff that we've done. So for KOH, we have 0.005 liters times, and we're going to excellent. We want to go from liters to moles. So for every 0.105 moles, it's in 1 liter. Now, this works because now we only have one hydroxide for one molecule. Okay, so 0.005 times 0.105, and that equals 5.25 times 10 to the minus 4 moles of OH minus, which is the same as the number of moles of this, of KOH. Now for the second part, okay, CaOH2, okay, so we have 0.015 liters, X line, liters on the bottom, moles on top, and the concentration is, and I'm going to write this as 0.095, okay, because I think that exhibits that these two are pretty close. Okay, so it's 0.095 moles for every 1 liter. Now watch what's going on here. So it's 0.015 times 0.095. And so this is 0.001425 moles of CaOH2. But we want moles of calcium hydroxide. So for every 1 calcium hydroxide, for every one of these, we have 2 hydroxides. So we have to take the 0.001425 moles of CaOH2, and we have to convert it to moles of hydroxide. So for every 1 calcium hydroxide, we have 2 hydroxide ions. Again, just to reiterate, the reason why that didn't have to happen up here is because for every 1 potassium hydroxide, there's 1 hydroxide, so it's a 1-to-1 ratio. Here it's a 2-to-1 ratio, so it's twice the number of moles. So we're going to take that value and we're going to multiply it by 2. So the concentration of hydroxide from calcium hydroxide equals 0.00285 moles. Now the total number of moles is going to be the moles of hydroxide from potassium hydroxide, this value, plus this value. Okay, so let's do that. Okay, so it's this, so it's that, if you look at my calculator right here. Okay, so it's this number. Okay, plus, what is it? What did I say it was? 5.25 times 10 to the minus 4. Okay, so we add them together, and we get that the number of moles, total moles, hydroxide equals, oh, sorry, not concentration, total moles of hydroxide, because that shouldn't be concentration either, okay, is equal to 0.003375. Now we can take this and we can do the math, because we have 0.003375 moles of hydroxide over, from the very, very beginning, we had 0.020 liters. And so we take that and we divide by 0.02, and we get that the concentration of hydroxide in that new thing is 0.16875. Okay? And so the concentration of hydroxide equals 0.169 molar. Okay, so now we need the pH. Okay, so it's kind of nice. So I'm going to find the pOH. pOH equals the negative log of this guy. So the negative log. Now you guys get to hear my announcement here. Negative log of the answer. So pOH equals 0.773. pH plus pOH equals 14. And so that means that pH equals 13.227. Okay? So that is the answers for 16.45, and have a great time trying to figure all that stuff out. Okay? As soon as